Hello everyone, welcome to Tacsfon Lautech Academy, and today we are treating physics. So one of the branches of physics we are treating today is mechanics. So I would like you to follow through. Alright, before we continue, I would like to explain to you that there are branches of physics, and one of the widest branches of physics is mechanics. And today we are treating dimension analysis, vector and scalar, kinematics in one dimension, and kinematics in two dimensions. Now know that in mechanics we have two aspects of mechanics, and which are kinetic and kinematics. Kinematics is studying the change in motion without the force causing the motion of the body. But kinetic is studying the motion and the force causing the change in motion. Alright, like we said, we are starting with dimension analysis, and I want you to follow through. Alright, dimension analysis. Like we know, here we'll be treating the fundamentals and the derived quantity. The fundamental and the derived quantities that we have. We have 7 fundamental quantities in physics. And what do we mean by fundamental quantities? These are quantities that they stand on their own without, they are dependent. They are independent rather. They can function without depending on other variable or other quantities. Example, we have the mass, we have the length, we have time, we have electric current, we have amount of substance, luminous intensity, until 1, 2, 3, 4, 5, 6, and the last one we have temperature. Alright, so here mass, which is the M, L, T, E, A, L, and T. Alright, these are the 7 fundamental quantities that we have in physics. We also have derived quantities. These are the quantities that actually generate from all these fundamental quantities. Example, we have velocity, so derived quantities. Derived quantities, which are velocity, we have acceleration, and so on. They are numerous. So one thing I would like to address here, okay, is the importance of these fundamental quantities. So, like we said, dimension analysis. Alright. Now, like we said the other time, we have velocity, we have acceleration, we have force. Let's put there. These are derived quantities that are gotten from the fundamental quantities. Okay, now what is the formula for calculating the velocity of a body? And this is displacement all over time taken. displacement over time taken, and for acceleration we have change in velocity. Change in velocity over time taken. Yes, let's say this, over time taken. And for our force, we have mass times the acceleration of the body. Acceleration of the body. Alright, so we are taking this one after the other so we can see how we get their dimension and how we get their unit. From their units we can derive their dimension. Like we said the other time, there are 7 fundamental quantities. But out of these 7 fundamental quantities, we have 3 major that we actually depend on to get the dimension of other quantities. Okay, so we have mass. Okay, mass, which is for m. We have length, which representing L, and we have time, which representing T. Okay, so these are the 3 letters we'll be playing with to get the dimension of every of these quantities. Alright, now for velocity, we say displacement over time taken. When we say displacement, that's a measure of length, but that has direction, a specified distance. Do you understand? So now for displacement, we can say the dimension to be length L, because it has the measure and the measure of what? Of length. So we have L, and for our time taken, that's T, like we know, so all over T. All over T. So we can say our velocity is LT raised power minus 1. Raised power minus 1 because it's coming from what? This division sign here. Hope you get that. Alright, for acceleration, which is change in velocity over time taken. Like we know, change in velocity is LT raised power minus 1 from here all over T, which is time taken. So from our indices, we can say LT raised power minus 1 times T raised power minus 1. Do we know how we get this? From 1 over T. Okay, so we have T raised power minus 1. Then we can say LT minus 1 plus minus 1, that's what? Minus 2. So this is the dimension for acceleration. Hope we get that. Alright, for force now, we have our mass times acceleration. Our mass, remember the letter we are using in representing it, which is what? M. So that's M LT raised power minus 2. Because acceleration is LT raised power minus 2. So simple. That's how to get the dimension of every of the quantities you can think of. Do you understand? So you can think of pressure. Think of, okay, let's say pressure now. Pressure. Pressure equals to what? Pressure equals to force over area. A specified area. So what's our force? Force is MLT raised power minus 2 all over. What's the area? Okay, I'm talking about area. It has the measure of what? Of length. So you're talking about length. Area is what? L, length times breadth. So this is still having 2L. L times L. So which equals to MLT raised power minus 2 all over L squared. So we can bring out 1L. So which equals to M L raised power minus 1 T raised power minus 2. I hope you get this. So this is how we get every of our dimension of every quantities that you can think of. Alright, from all these dimensions we can get our units also. Hope you know that.